Hey everyone, welcome back to the channel. Today, we're embarking on an incredible journey, one that stretches billions of miles into the cold, dark expanse of interstellar space. We're going to talk about two of humanity's most ambitious explorers, the Voyager 1 and Voyager 2 probes. Launched way back in 1977, these twin spacecraft have traveled farther and longer than any other human-made object. They are our silent emissaries, our ghostly envoys to the cosmos. But where are they now? And what are they doing? Let's find out. First, let's just appreciate the sheer scale of this mission. When Voyager 1 and 2 were launched, their primary goal was a grand tour of the outer planets, Jupiter, Saturn, Uranus, and Neptune. This was a once-in-a-176-year opportunity, a special planetary alignment that allowed them to use gravity assists to slingshot from one planet to the next. It was an incredible feat of celestial mechanics, and the data they sent back completely rewrote our understanding of these gas and ice giants. We saw volcanic activity on Jupiter's moon Io for the first time, discovered the intricate details of Saturn's rings, and got our first ever close-up views of Uranus and Neptune. But the grand tour was just the beginning. After they completed their planetary flybys in the 1980s, their mission was extended. Their new objective, to reach the very edge of our solar system and cross into the vast unknown territory of interstellar space. To do this, they had to travel through the Heliosphere. Think of the heliosphere as a giant magnetic bubble created by the sun. This bubble is inflated by the solar wind, a constant stream of charged particles flowing out from the sun in all directions. This bubble protects our solar system from a lot of the high-energy cosmic radiation that fills the rest of the galaxy. For decades, the Voyager probes traveled outward, measuring the properties of this bubble from the inside. So, where is Voyager 1 right now? As of today, it's over 15 billion miles, or about 24 billion kilometers, away from Earth. To put that into perspective, light, the fastest thing in the universe, takes more than 22 hours to travel from Voyager 1 back to us. When you send a command to the spacecraft, you have to wait almost 2 full days for a reply. It is the most distant human-made object in existence. In August 2012, Voyager 1 made history. It crossed the heliopause, the boundary where the sun's solar wind is stopped by the interstellar medium. It officially entered interstellar space, becoming the first object from Earth to do so. It is now sailing through the space between the stars, a region filled with gas, dust, and radiation from other stars that exploded millions of years ago. It's truly out there, in the cosmic ocean. And what about its twin, Voyager 2? It's not quite as far, currently at about 12.5 billion miles, or around 20 billion kilometers from us. It's traveling in a different direction from its sibling. Because of its trajectory to visit Uranus and Neptune, its path was slower. But in November 2018, it too crossed the heliopause and entered interstellar space. This was a huge deal for scientists. Having two probes in interstellar space, in different locations, allows them to get a much better, more three-dimensional picture of what this boundary region is actually like. It's not a smooth, perfect bubble. It's a dynamic, turbulent frontier, and the two Voyagers are giving us our first direct measurements of it. Now, you might be wondering, if they're so far away, how are they still working? It's a testament to 1970s engineering. They are powered by radioisotope thermoelectric generators, or RTGs. These are essentially nuclear batteries that use the heat from the natural decay of plutonium-238 to generate electricity. They don't have any moving parts, which is key to their longevity. However, their power output is decreasing by about 4 watts per year. To conserve this precious energy, NASA engineers have been systematically shutting down non-essential instruments and heaters over the years. It is a delicate balancing act to keep the most important scientific instruments running for as long as possible. Recently, you might have heard some news about Voyager 1 acting a bit strange. In late 2023, it started sending back gibberish. Just a repeating pattern of ones and zeros instead of usable science and engineering data. For months, the mission team at NASA's Jet Propulsion Laboratory was in a state of high suspense. They couldn't just reset it. They had to perform a kind of remote brain surgery from 15 billion miles away. After months of brilliant detective work, they traced the problem to a single faulty memory chip in one of the onboard computers. The solution was incredible. They couldn't fix the chip, so they devised a plan to slice up the affected code and store it in different spots in the computer's memory, and it worked. In April 2024, they successfully restored the flow of engineering data. And a month later, the science data started coming back to. It was a remarkable recovery for a nearly 50-year-old spacecraft. Both probes are still collecting data, measuring the characteristics of interstellar space, the magnetic fields, the cosmic rays, the density of the plasma out there. This is science that simply cannot be done from within our solar system. They are our first and only direct samplers of the galactic environment. This information is crucial for understanding the bubble our solar system lives in and how it interacts with the rest of the Milky Way galaxy. But the Voyager mission is more than just science. It's also a cultural mission. Attached to the side of each spacecraft is a golden record. This is a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. It was designed by a committee chaired by the legendary astronomer Carl Sagan. There are 115 images, sounds of wind, rain, and animals, music from different cultures and eras from Bach and Beethoven to Chuck Berry's spoken greetings in 55 different languages. It starts with a greeting from the UN Secretary General at the time and ends with a message of hope. The chances of an alien civilization finding the golden record are infinitesimally small. The probes aren't aimed at any particular star. They are drifting silently through the void. In about 40,000 years, Voyager 1 will come within 1.6 light-years of a star called Gliese 445. In about 296,000 years, Voyager 2 will pass within 4.3 light-years of Sirius, the brightest star in our night sky. These are just cosmic flybys. The records are really a message in a bottle, cast into the cosmic ocean. But perhaps more importantly, they are a message to ourselves. They represent a hopeful vision of humanity, a statement about who we are and what we aspire to be, preserved for eons. They are a time capsule of our world. In 1977, the journey, however, is slowly coming to an end. By around 2025, or perhaps a few years later, if we're lucky, there won't be enough power left to run any of the science instruments. The transmitters will fall silent, one by one. Communication with Earth will cease forever. But their voyage will not stop. They will continue to drift through the Milky Way galaxy for millions, even billions of years, carrying their golden records. They will likely outlast humanity itself, outlast the Earth. They are our quiet, ghostly representatives, carrying a memory of our world long after we may be gone. When you look up at the night sky, remember that out there, beyond the furthest stars you can see, two small, resilient machines are still flying. They carry our music, our languages, our image, and our hope. They are a profound symbol of human curiosity and our relentless desire to explore the unknown. The story of Voyager is a story about reaching for the stars, both literally and figuratively. It's a reminder that even with limited technology, a grand vision, and incredible ingenuity can take us to places we've only dreamed of. Thanks for joining me on this deep dive into the Voyager mission. It's a story that never fails to inspire. If you enjoyed this journey to the edge of the solar system and beyond, please hit that like button and subscribe for more stories about science and space exploration. Let me know in the comments what you find most fascinating about the Voyager probes. Until next time, keep looking up.